Every year, the world produces over 4 billion tons of cement. This gray powder begins as ordinary limestone and clay, mined from the earth. Inside cement factories, these materials are crushed, heated to nearly 1450 degrees Celsius, and chemically transformed. What comes out is clinker, the key ingredient that holds modern cities together. This is how cement is made. It is the main binding agent in concrete and is produced through a controlled industrial process involving raw material extraction, high-temperature chemical reactions, and mechanical grinding. This video explains how cement is made in factories, from raw limestone to the final powdered product. The primary raw material used in cement production is limestone, which contains calcium carbonate. Other materials include clay, shale, sand, iron ore, or bauxite, depending on the chemical composition required. These materials are extracted from open-pit quarries using drilling and controlled blasting. Large rocks are transported by dump trucks or conveyor belts to the cement plant. At the plant, the quarried limestone passes through a primary crusher, usually a jaw crusher or hammer crusher. Large rocks are reduced to pieces about 10 to 20 centimeters in size. Crushing increases surface area and makes further processing efficient. The crushed material is stored in covered stockpiles or silos to ensure consistent supply. Cement quality depends on precise chemical composition. The main oxides required are calcium oxide, silicon dioxide, aluminum oxide, and iron oxide. Computer-controlled systems analyze the raw materials and calculate the exact proportions needed before grinding. The raw materials are fed into a raw mill, typically a vertical roller mill or ball mill. Materials are ground into a fine powder called raw meal. Particle size is usually below 90 microns. Hot exhaust gases from the kiln are often used to dry the material during grinding. The raw meal is stored in blending silos where compressed air is used to ensure uniform chemical composition. The raw meal is transported to a preheater tower, which consists of multiple cyclone stages. Hot gases from the kiln heat the raw meal to about 800 degrees Celsius. Moisture is removed. Partial chemical reactions begin before entering the kiln. This step improves fuel efficiency and reduces energy consumption. Inside the lower part of the preheater, or a separate calciner, limestone undergoes calcination. Calcium carbonate decomposes into calcium oxide and carbon dioxide. The reaction temperature is approximately 850 to 900 degrees Celsius. CO2 is released as a byproduct. This step accounts for a large portion of cement's carbon emissions. The material then enters a rotary kiln, a large rotating steel cylinder lined with refractory bricks. Length is up to 60 meters. Temperature is up to 1450 degrees Celsius. Inside the kiln, raw materials partially melt and chemical reactions form clinker minerals such as alite and baelite. The material exits the kiln as clinker, small gray nodules. Hot clinker is rapidly cooled in a clinker cooler. Cooling air recovers heat and sends it back to the kiln system. Rapid cooling improves clinker quality and energy efficiency. After cooling, clinker is stored in silos. Clinker is mixed with 3 to 5% gypsum and sometimes additional materials, such as fly ash, slag, or limestone. This mixture is ground in a cement mill, ball mill, or vertical roller mill. Grinding controls cement strength and setting time. The final product is a fine powder known as Portland cement. Finished cement is stored in sealed silos, protected from moisture, quality monitored continuously. Different cement types are stored separately depending on composition. Cement is either packaged in 25 or 50 kilogram bags using automated packing machines or transported in bulk using tank trucks or rail wagons. From here, cement is delivered to construction sites, ready-mix plants, and distributors. Throughout the process, laboratories test chemical composition, fineness, setting time, and compressive strength. Modern cement plants use real-time sensors and automated control systems to maintain consistency.
Cement production is a highly controlled industrial process involving geology, chemistry, and mechanical engineering. Each stage is designed to ensure consistent quality, strength, and performance. This process allows cement to be produced at the scale required for global construction.